Unit 18, Part 3. So we just got to the stage where we found that if we derive this, the second of the two conjuncts I need for the instance I need to do the e.g., which will get me home, gets me my conclusion. So this is the second instance I need. So taking stock of what I've got here, my premises were an existential statement and a universal statement. I'm always going to be doing EI before UI, and I haven't even done UI. Notice the 2 I haven't touched, right? Because I'm not quite sure what instance I want to instantiate to. Right. When you do UI, you have a choice of which letter to instantiate to. The choice of all the letters, even the flagged ones, right? A lot of doing these proofs, as I mentioned, is matching. And that matching is, as it were, resolving your choice for the universal instantiations, making sure you instantiate to the correct letter, correct in the sense in that it'll give you the formulas you need to make the moves you need to make to get the conclusion you need, right? It's very abstract. You'll see how it works in practice, but we haven't universally instantiated from 2 or 5, right? We did an EI, which we would have to do, and we always have to flag that letter. So we're always going to have to flag a letter. No way to get information out of one without flagging a letter, right? So we have to do that. And then we just had a conjunction, so we simplified, right? But now, where are we? This PA is obviously going to be used as in the conj. This is going to be gotten by conj. Right? We can even write for question mark, right? For and whatever this step turns out to be. That's the other conjunct we need. That's what we're aiming for. We don't have it. We've determined that we need it, right? So that's what so what are we paying attention to? 2, 5, and this, right? We've got the two universal statements, and a universal statement as a conclusion, okay? This universal statement, right? It is a universal, right? Starts with the universal quantifier, scope of the initial quantifier goes to the end. It's for all y. If y is a puppy, then a does not like y. Notice there's an a there. Right? But this is a universal. How do we derive them? By universal generalization. Universal generalization, that's the hard rule. The harder of the two hard rules, the hardest rule. It's the one that requires setting up a flagging subproof, hard before easy. Second application, set up for UG before you do UI. And that's really crucial you do that here, before you do those UIs. Okay, so I'm going to set up here, step 6, flag what? I cannot flag A because A has already appeared in the proof. I did the EI to A. A is appeared to the proof. So this will be a B flagged subproof. Flag B, flagging step, brackets. Flagging step for UG. Okay, that's step 6. B has now appeared in the proof. Now, remember, universal, so I know I'm going to get this by UG, by what number? I don't know yet. I'm writing this down, but I haven't justified this. I still need to get this. I will be able to infer this from this instance if I can derive it, right? Still got to derive it. Don't know how I'm going to get it yet, but I'm working my way backwards to see further and further the things I need to get home. Right, UG, like conditional proof, has the advantage that you know exactly what formula goes here. That is what instance knows. You know the specific, you can derive, you can state, when you set up for UG, you can state the specific instance you need to do the UG. That's like conditional proof, because conditional proof, you can infer a conditional if you assume the antecedent and derive the consequent. So when you do the working backwards, set up the conditional proof, you write the antecedent as your assumption, and you write the consequent as your conclusion of the subproof. So you know that when you get to that specific formula, you've ended your subproof, discharge the assumption, and infer the conditional by CP. It's an advantage that CP didn't have over IP. You guys all know that because you're Top Gun, and you've heard me say it many times before. So what's the specific instance? Right? Generalization, the opposite of generalization. Generalization is the opposite of instantiation. So deriving this instance, okay, UG, I'm going to replace, okay, it's a B flag subproof, so this is going to have to be something true of B, right? I'm going to have to replace B with, what quantifier am I adding on the left? Y, right? So I'm going to be replacing B with Y. Let me again say Y. It has to be a B flag subproof at this stage. Why? Because the existential instantiation has already resulted in flagging A. So A has appeared in the proof. Right. Setting up a UG flag subproof is a flag step. So you can only flag to a letter which is new to the proof, which has not appeared previously in the proof. That's the first rule of flagged instances, flagged letters. Okay. So, and this has to be an instance saying something about B, saying something true about B, such that I can replace that B with the variable in doing the universal generalization. So the Y, I'm adding the Y, that's clear from just the fact that it's a Y here. I'm going to add the Y, I'm going to replace the B with a Y, right? So doing that instantiation, this looks like this. U, B, Y goes to B, hook, not, L, A remains in place, and Y becomes B. Okay? That's all the hard stuff, right? That's all the new stuff and all the hard stuff. Remember what I said in part 1 in setting this up? Be on the lookout for how EI information can now combine with UG information in these relational predicate logics. Something that wasn't possible, we didn't want it to be possible, in monadic predicate logic. Right. Pause and make sure you can do the rest of the proof from here. Welcome back. You guys are Top Gun, should be pretty easy, right? So you've got, but still I'll run through it because it's important what pops out here. Okay, this is the specific instance I need. Where am I going to get it from? Our attention was on 2 and 5, right? We've already got the information that was in 3 became 4 and 5. 4 is going to, step 4 is just PA, it's going to go there. So we've got this universal statement, and we haven't done anything with 2 yet, that universal statement, okay? Those are universal statements, so you universally instantiate from them, and universal instantiation, you can instantiate to whatever letter you want. UI is a non-flag rule. It's an easy rule. Right? There is no restrictions on which letter you flag to in universal instantiation. But here that's kind of a problem because it gives you choice, and you completing these proofs, solving these proofs is a matter of resolving these choices in the right way. Okay, so here's where you have to pay attention. Right, so from 2, by the way, you can set up for a conditional proof, that would be fine. It's a conditional. Let the form determine what you do. UB, right, not L, AB at the bottom, that's fine. I won't do it that way, you don't need to do it that way. There's several ways to get home from here, all pretty easy. But the crucial thing is, right, you do need UB, right? UA will not do. Andrew is a puppy. It's UX is, X is a puppy, yeah. Andrew is a puppy, won't do. B, so it's, B is, what's a dog name? Barker? Barky? Barky is a puppy. Whatever. It has to, the individual has to be B that makes this connection, right? What it means is both 2 and 5, you're replacing the universal quantifiers with B. Doing the universal instantiations of 2 and 5, you have to replace, in turn, the X for 2 and the Y for 5 with B in order to match the formulas to get not LAB and to get UB, to get to this formula. If you were to universally instantiate to A, try it, you won't get home, It's not illegal to universally instantiate to A, yes, right? It's legal to universally instantiate to A. That's something you can do. But it won't get you there, right? That choice is sort of bad because it can lead you astray. So seeing that this is what you need, right? It's just, so I'll do 2 UB, hook D, B, UI 2, and this is now B for X. Step 8 is, okay, I'm now UIing from 5. I'm going to do UI on 5, right? I'm replacing Y with something, okay? I want it to be, so see how my thought is determined, right? I've got a choice to replace the Y with an A, or I could replace the Y with a B. What should determine my choice? Matching, right? I want the D to be what? I want it to match this and this. This? Yes, this. Just this. This is the only other instance of the D. I want that to match that. And also, second part of matching, right? I want the LA question mark to match the not LA, what do I replace it with? To match the not LAB. I want that to match, right? So I'm doubly determined. You've got to be determined at least once. I'm doubly determined to replace the Y with the B, right? What does the Y become? A or B? Answer, right? B, Y, Y, W, H, Y, because there's a B here, and this is, you know, after I'm going to replace that with, it's not L, A. What do I replace the Y with? B, because of these two matchings. All the proofs, this matching is crucial to getting home. Since that's B there, I want it to be here, so my information connects, right? And since it's not LAB here, I want a B here. If I did LAA, that would not be the same form, right? Not LAA does not equal not LAB. DB does not equal DA. Those are different formulas. DB, those are identical, right? And now, the way Klenk does it is hypothetical syllogism to there, and then write in the numbers. It's a Top Gun. You don't need me to annotate the rest of the proof. That's how you do it. Of course, you can. If you did conditional proof, you could modus ponens your way there. Easy enough.